All right, and problems number 7 through 11 that I've assigned, the book doesn't really give you a lot of instructions, but I added some instructions on your assignment sheet. They want us to graph it, and that's all they say, graph it. Follow the method of example 2. Well, if you go look at example 2, they should have just said, what they should have told you to do was to change it. Right now it's in standard form, okay? But what example 2 is, if you look at it, it's in vertex form. So what they're wanting me to do is change it from this form into the form y minus k is equal to a x minus h squared. And how do I do that? I complete the square. Okay, so that's what I got to do here. I'm going to complete the square, and that will put it in that form and make it easier to graph. All right, so here we go. If I'm going to complete the square, I take the equation, x squared plus 2x minus 3, and I set it equal to 0. Now, if you remember when we completed the square, what we did is first we moved the constant term over to the other side. I'll add 3 to each side. Okay, now that gives me x squared plus 2x is equal to 3. Now to complete the square, I'm going to add something to both sides. And what I add is I take the b term, which is the coefficient, I'll circle it in yellow, it's the coefficient of the x term, which is it's a positive 2 here. So what I do is I take that b, and I'm going to divide it by 2. So I take the 2, I divide it by 2, and I square it. If you remember what we do is we say b divided by 2 squared. That's what we add to both sides. Well, that is really a 1 squared, isn't it? And 1 squared is 1. So let me just put a 1 over here. Now, what that did when I added that b over 2 squared to both sides, it turned the left-hand side into a perfect square. That perfect square, I'll always write x, and then inside of the parentheses where I added the b over 2 squared, 2 divided by 2 is positive 1. So I'm going to put a plus 1 squared. Whatever's in the parentheses is what you write there on your perfect square. Now on the right-hand side, 3 plus 1 is 4. Okay? Now, what I'm going to do, this is kind of weird, how you have to turn it back. I like teaching this a different way, but because of the way your book presents it, I'm going to go ahead and do what they do here. If I want to now, I can say x plus 1 squared, and let me move the 4 to the other side by subtracting it, minus 4 is equal to 0. Well, what did I do at the very beginning? I set the equation. Remember, this was the h of x really stands for y. I temporarily set y equal to 0 just so I could work on this. We take the equation, we set it equal to 0. What we're really doing is we're setting y equal to 0. Now that I've done all this and I got a 0 on the other side, I'm going to switch it back to a y. That's one of the reasons I moved the minus 4 over temporarily. So I have this, but that doesn't look like my vertex form up here. It will if I just move forward back to the other side now. I know that's kind of weird to move it and then move it back, but that's the best way to explain how you would put it back in that form. So I end up with x plus 1 squared is y plus 4. Okay, I'm going to rewrite it here. Now, if I were to put the y plus 4 over here, just switch the sides of it, I now have it in vertex form. Remember, vertex form is y minus k equals a x minus h. If you remember, my vertex is important to graphing, isn't it? My vertex is hk. Okay? So my vertex, if you look at your h here, it's negative 1. Remember, it's the opposite of the way it looks in the equation. And if I look at my k, it's a negative 4. It looks like positive 4, but it's really negative 4. Now, if I'm going to go graph that, and I'm just going to make a rough sketch, you'll need to be more careful on your paper, but just because of the limitations of this iPad, this is what I'm going to do. Negative 1, let's do some little marks here. Negative 1, negative 4 would be, let's say, about right here, okay? Try to make it bigger. Now, what things can I do now? What do I need to add to my graph? Well, it's important to get your vertex, your x-intercepts, and your y-intercepts. I want you to also remember that you actually have something else going for you here. Once you get your vertex down, you have an axis of symmetry that goes through your vertex. So that might help you graph as well. So let's do some of the things that they asked you to do on the first part. Let's find our x-intercept. To find the x-intercept, we set y equal to 0. Okay, so let's take the equation, and I'm going to use the equation. I'm going to take it the way it's written right here, and I'm going to set y equal to 0. So that's going to be 0 plus 4 is x plus 1 squared. Well, that's just going to be 4 is x plus 1 squared. And I'm going to square root both sides, and once I square root, I have to remember to put a plus or minus, and I get x plus 1 equal plus or minus 2. So I'm going to have two x-intercepts. One of them is going to be x plus 1 equal positive 2, and the other one's going to be x plus 1 equal negative 2. So if we solve, subtract 1 from both sides on the first one, we get x equal 1. So I've got an x-intercept at 1, 0. So that'd be about right here. Try to make it extra big so it'll show. Now for the other x-intercept, I'll solve this second little equation for x. I'll subtract 1 from both sides, and I get x equal negative 3. Okay, so negative 1, negative 2, negative 3. If you think about it, that makes sense. If you count to the axis of symmetry from negative 3, 0, it's 2 over 1, 2. And if you count from this one, it's 2 over to the axis of symmetry. So we know we're looking pretty good. Now the y-intercept I could find by setting x equal to 0. There's an easier way to do it here. If you look back at the original equation, it had a, I have to flip to find it. I've flipped over too many times. You could look at it. They gave us the equation in standard form, and in standard form, the y-intercept is the number at the end of the equation. It's negative 3 in this case. I'll go ahead and graph it, but I'm going to show you that even if I didn't remember that, I could find it. Because for the y-intercept, all I got to do is set x equals 0, so I could go back to my equation, y plus 4. I'm going up to that equation I circled in green. I'm going to plug in x is 0 there. So I get y plus 4 is 1 squared, which is 1. Subtract 4 from both sides. Y is negative 3. So I've got my vertex, I've got my x-intercepts, and I've got my y-intercepts. If I wanted to, I could get another point pretty easily. My y-intercept is 1 over from the axis of symmetry, so I could go put another point 1 over the other direction. Now I'm going to graph. I'm going to use like a purple just so it shows up. I'm going to join all those points, and I've got my graph. This is how you really should be doing 7, 9, and 11, and this will help you also practice the best way possible for your test, because there's several questions on the test where you have to do some stuff that would involve this process here. One more. Let me do number 11, because the one on the test looks a lot like this as far as the way they have it set. It's not exactly like this, but 11 and 12 look the most like the test question. First of all, they give you something that is not it's in standard form, but it's even not in proper standard form. They put the constant first. Okay, so let's do this. Let's say first of all, we got to remember this is really y, isn't it? And I want to change this from standard form into vertex form. But before I do that, let's go ahead and put it in the proper order. That's negative x squared plus 2x plus 5. And we want to complete the square. And so to complete the square, I'm going to write these over here. We set y equal to 0 temporarily. Okay, so temporarily set y equals 0 to complete the square. Now, when we complete the square, if you remember, we cannot have a negative in front of our x squared term and do it. We have to get rid of the negative first. And the way they told you, if you had anything in front of your x squared term, you had to divide it out. So what I'm going to do is divide everything by negative 1. Okay? That turns this into now x squared minus 2x minus 5 equals 0. Now, when we complete the square, now we got it set up where we can actually complete the square. So we had to do some things to it first so we could actually complete the square. Now to complete the square, we're going to move the constant to the other side. So I'll add 5 to both sides. And that gives me x squared minus 2x, and I'll have a 5 over here. And what I want to do now is add b divided by 2 squared to both sides. Well, what is my b here? It is this negative 2. So I'm going to add negative 2 divided by 2 squared. And what is negative 2 divided by 2? It is negative 1. But when you square it, it's a positive 1. So let me write a plus 1 over here. So you could put plus negative 2 divided by 2 squared on the other side, or you can just go ahead and figure it out and write it as a whole number over there. That's what I decided to do. Now what did that do? That on the left-hand side, that created the perfect square, x, and then look inside the parentheses. What's there? Negative 2 over 2 was a negative 1. So we do that. It's minus 1. X minus 1 squared. And over here we get 6. Okay, you may can see this is not going to be a pretty answer. As a matter of fact, when we go to graph this answer, we're probably going to want to change it into a decimal. And the reason I'm saying that is if I square root both sides, I put a plus or minus, is square root of 6 going to be a nice pretty number? No. So I have x minus 1 is equal to plus or minus square root of 6. Alright, I was copying this information to the next page and realized that I had done something that I wish I hadn't done. And that is, on the previous page, I had taken this and I had started to solve it. Is that what I really wanted to do? In a minute, we're going to see that this is actually some useful information. But that's not what I really wanted to do. I was trying to put this in vertex form and I got carried away. So let me backtrack a minute. When we had x minus 1 squared is 6, I could solve that. And by the way, since y is set equal to 0 here, this is going to be my x-intercepts over here. But that's not the order I showed you in the last video, so I'm going to kind of backtrack and do it in the same order in case you get confused. Okay, I have this. Instead of solving, what I want to do, if you remember, I want to put it in vertex form, so I want to get my y back in there. So if you remember what I did is I subtracted 6 from both sides. I'm subtracting, not dividing there. I just had underlined it just to show you where I was at. So this gives me a 0 here, and now I have x minus 1 squared minus 6 equals 0. But at the very beginning, I had temporarily set y equal to 0. Now that I've got 0 over here again, I'm going to put y back in for it. So I'm just going to take it out and put y back in, because I'm trying to get an equation so that I can find my vertex, okay? So now I've got that, but that doesn't quite look like vertex form. But if I move the 6 back now, I moved it temporarily just to show you why it worked. What I have now is x minus 1 squared is equal to y plus 6. And if I just were to switch the sides on it, it would look like vertex form. Y plus 6 is equal to x minus 1 squared. This is my vertex form. Let me write vertex form under it again, just so you can see that that's what I have. Alright, so what's my vertex? My vertex here is HK, right? Well, what is the H? Remember, the H goes here, the K goes here. The H is 1. Remember, it looks like a minus 1, so it's really a 1. The K is negative 6. It looks like a plus 6, so it's really a negative 6 in the formula. So I could go graph that. Now, I'm not going to